Okay, welcome to the final session at Repository Fringe 2008. I'm very pleased to be able to introduce our closing speaker, whom I've known for all my professional life, but who I still need to refer to the web in order to get his bio right. So David Roure is Professor of Computer Science at the School of Electronics and Computer Science at the University of Southampton. He's been a founding member of our Intelligence Agents Multimedia Research Group, and he leads the e-research activities and is Director of the Pervasive Systems Centre. His current research interest is the application of semantic web, Web 2 and workflow technologies to enable new research in multiple disciplines. He is a pioneer of the semantic grid and closely involved in the UK e-science programme with activities including CombiChem and MyGrid projects, OMII UK and MyExperiment. With the Open Grid Forum, he is e-science area director and a steering group member. David has worked for many years with distributed information systems, distributed programming languages, and has been active in the web and hypertext communities. He's a scientific advisory council member of the Web Science Research Initiative and a fellow of the British Computer Society. And you should see his carbon footprint. And so I'm really pleased to welcome David here today to give us a perspective on repositories from the point of view of someone who's seen lots and lots of information systems initiatives come and go. And so he's going to talk particularly with respect to the latest and greatest, the one that's been attracting all of the attention and all of the funding, e-science, cyber infrastructure, as Dorothea will know it, and ask us how can we avoid failing like the last big failure. So thank you very much, David.
Thank you, Les. This is a great title. Les gave me this title. In fact, I was waiting to meet someone outside Westminster Abbey and the phone rang and it was Les, and he read out the title and said, "Is that okay?" And I said, yeah, fine. and then I read it. But it's great, and I'd like to speak for about 3 hours on this, but I'm not going to. I've managed to cut my slides down to 30 minutes so that we can discuss some things. And my only real qualification for being here, I think, is that I got a foot in both camps. And I've often done that, and it's very interesting comparing what's going on in different communities. So the title made the assumption that the grid is failing. And of course, that's an outrageous suggestion, because we see many declarations of success for the grid. We have in the UK the National Grid Service, largely funded by JISC and providing infrastructure for us all. We have in the States, for example, TerraGrid, huge investment, masses of computation, doing very important things with earthquakes in this particular example. Open Science Grid with, that looks like storm prediction. So clearly, a lot of money has gone into this grid infrastructure, this infrastructure that provides computational resource and data resource in order to do some really big science. And that's clearly successful, isn't it? Similarly, if you look out of Alcove 4, you will see this view. I've got the arrow pointing the right way, because that building there is the National E-Science Centre, okay? The gateway to the rest of the world for grid computing and e-science in the UK. And has done a fantastic job in e-science. But if this is all such a success, why, at this point in time, can I easily identify 3 projects in the UK under the following titles? Engaging research with the infrastructure. I know about that one, it's mine. E-uptake, enabling uptake of e-infrastructure services. AIS, e-infrastructure use cases and service usage models. These are the projects which are trying to work out why people aren't using the infrastructure. Okay? And they're very, very interesting. And it's one of the great things about e-science as opposed to cyber infrastructure is that it was e-science, which means the same as e-research. And therefore it was about the science and not about the infrastructure. It wasn't just technology push, it was about doing new stuff. Except still, despite that, it seems that the users are something of a retrofit. So later on in the program, people started thinking about usability and about users. And shouldn't we have thought about that first? Okay, so you can see where I'm coming from here. And that's what these projects are doing. They're talking to the users. Another theme in the eScience Institute, just out the window, adoption of e-research technologies. So There's a lot of reflection now on why we haven't got thousands and thousands of users of the National Grid Service, for example. So how did we get into this situation? Well, there was early adopter success. There were various bits of software, grid middlewares like Globus, that were built, adopted in particular projects, and led to new scientific outcomes. And then from that, this rollout of, this acknowledgement, as we've heard earlier today, that you have to see things as services rather than something from a community of enthusiasts. And eventually these things roll out as services, and there's investment, and you get the institutional arrangements to deliver these things. And then people wondering where the users are. Does that sound familiar? Right, so this might be the link. This is why this talk is relevant. So when I came yesterday and I heard the opening video, welcome, it was very interesting to see that sentence. How do we persuade researchers to populate our repositories? Because that rings an alarm bell, right? For me, because that is exactly the question the grid community is asking itself now. How do we persuade researchers to use the grid? So perhaps we can learn something. Let's reflect now on how the grid got to where it is, and how eScience got to where it is, and how we might do things differently. So the key word in that is researchers. That's what this is actually all about. So let's look at eScience. That was the definition of eScience from John Taylor, Director General of the Research Councils, back at the beginning of the eScience programme earlier this decade. And that's a nice definition. eScience is about global collaboration in key areas of science and the next generation of infrastructure that will enable it. So what's happened? Well, I had a look at Wikipedia to find out what the definition of eScience is now. And according to Wikipedia, it is, due to the complexity of the software and the back-end infrastructural requirements, eScience projects usually involve large teams managed and developed by research laboratories, large universities, or governments. So we have had that success in the big science piece. And my focus here is not on what I describe as the heroic scientists doing heroic science with heroic infrastructures on heroic budgets. That isn't the focus here. Let's ask what we're really trying to achieve. Are we trying to get everyone using the grid of repositories? Or are we actually trying to enable research advances, scholarly advances, educational advances on an everyday basis that wouldn't have happened otherwise? And you can guess my answers to these two questions, because this is a kind of Web 2 talk. We have big, bold icons here, so the answer to the first one is no, and that's yes. And actually, in the grid world, people talk about acceleration all the time, the research happening quicker, and that doesn't interest me. I'm interested in stuff that wouldn't have happened otherwise. Okay? And that's one of the really, really exciting things about the repositories world, because that is where you can enable stuff that wouldn't have happened otherwise. So this is my question, which has been the motivation for my talks since about last December. And if you look on a Web 2 slide sharing site called SlideShare, you will find a presentation which is a longer version of the next 8 slides, which I gave well, in various places since the IEEE eScience conference last December. So how do we move from heroic scientists doing heroic science with heroic infrastructure to everyday scientists doing science they couldn't do before? I don't like the word everyday, but I haven't got a better one. And if anyone could help me, that would be great. These are the PhD students and the research fellows and the research assistants who are just doing their stuff and supporting research projects and so on, rather than the really big science piece. There is a suggestion for another word for that, which I'll come on to. I just want to correct a couple of things here. We had this sort of branding issue in eScience, because eScience is really e-research, but it got called eScience. And then when the Arts and Humanities Research Board became Research Council and they became part of the eScience programme, we were all willing to change to e-research, but they stuck to eScience because it's a brand. So eScience actually means e-research, and I shall try to say e-research, not eScience in this talk, but I often fail. So it's actually about research, and it is across all disciplines. It is humanities, archaeology, geography, musicology, any kind of researchers. And in some sense, this is about the democratization of research. Here's another word instead of everyday science. So Peter Murray Rust, who I had the privilege of spending 2 days with in Seattle earlier this week, is using the phrase long-tail science, which is quite an interesting phrase. Doesn't have that diminutive aspect of everyday, which is coined from Jim Downing. And actually, Peter, you may have heard him give talks on this, actually questions whether institutional repositories are appropriate for this kind of science, and that sets the scene for what I'm about to say. So let's focus on these researchers. What do researchers do? Well, they do experiments. These are quite scientific ones. There's a chemist in a lab. This is someone doing an in silico experiment using a workflow. And a lot of the focus of the eScience program has tended to be in that part of the cycle, dealing with the quotes data deluge that comes from new experimental techniques. In bioinformatics, it's DNA microarrays. In chemistry, it's combinatorial chemistry. Parallel experimental techniques generating huge amounts of data, sensor networks, environmental sensing, and so on. So because of that, that's really where the grid and the cyber infrastructure's got focused. But we have to remember that this is a life cycle. You will know this already, life cycle. I'm just looking in the audience and spotting Simon probably even drew this picture. So there's been a lot of discussion about the left-hand side of this picture over the last 2 days. And this is the current process of science, and it reminds us that it's about people and it's a social process. But I want to add to that the thing that very important, students. I want to add to that the thing that sort of brings the 2.0-ness to this. In this increasingly digital world of e-research, we have new forms of digital artifacts coming out. We have the data itself, which has been discussed a little in these 2 days. We have metadata, which we're all very good at. We have provenance. Provenance is vital to researchers because it enables them to reuse the data and enables them to trust the data. So it's absolutely key piece of digital artifact that we now have to play with as well. We have the workflows, like in my middle example there, where scientists are automating the processing so they can do systematic processing of the large volumes of data, and so they can share their research methods with others. We have the ontologies and the shared controlled vocabularies and so on in our different domains. So we have these new forms of artifacts to play with, and over on the right-hand side of the picture we have, if you like, the blog sphere and the Web 2 world. I happen to have put my experiment there. Now, I'd love to give you a talk on my experiment, and in some senses this is a talk on my experiment, but if you want to know more, go to myexperiment.org. This is a Web 2 site for scientists that I run. I was wearing the t-shirt yesterday. Today I'm wearing an OMI Europe t-shirt for ironic sartorial juxtaposition with the Science Institute. And so I won't say more about my experiment now, but it's a place where scientists can share data. In particular, they can share collections of stuff, because scientists work with collections of data, not individual pieces. And for that, of course, you can export things in ORE, and that's another talk. But we won't go there. What I'm trying to do these days is link up what's on the right-hand side of here, which is a vibrant blogsphere world of how people are actually communicating and how they're using the Web 2 tools to support the science and the research, up with what's going on the left-hand side. And that would be another talk. So there is this sort of 2.0 thing going on here, and there are loads of definitions of Science 2.0 out there, like there are loads of definitions of Web 3 out there and so on. I want to give you my definition of Research 2.0, and this is entirely based on very real experience. In fact, I had a pile-up of conferences last year, around October time, and I had Grid 2007, sort of mainstream grid conference, Scientific and Scholarly Workflows in Washington, which is a lovely combination of communities, eSocial Science in Ann Arbor, went to the W3C, World Wide Web Consortium meeting in Boston, Open Grid Forum in Seattle, Microsoft eScience in North Carolina. It was really nice to have a trip and do all the conferences in one go. It was really nice to attend everything without being jet lagged. And on the plane on the way back, I wrote an email. Because I had at 38,000 feet this sudden sort of reflective moment about everything that I'd seen. And I sent the email to various people in the eScience community, and really it was me getting at something that was frustrating me. Because in the UK at that point there was a discussion about what's the future of eScience, and I was really not happy with the anticipated directions, and I felt there was something new and exciting going on that wasn't being captured. So I sent this email, subject to the new eScience, to a few people, and it travelled. And then I was invited to give a, quote, provocation talk, actually there in Nesk at a think tank. So I converted the email into 8 slides, right? That must be the easiest set of 8 slides I've ever produced. And these are the 8 slides. Now, I'm going to do these quite quickly, and if you want to study them further, you can look at them later. But actually, you know everything in them, and the relevance of this is a kind of meta-level thing, because it's, you'll see in a minute how I've divided up the issues. So the first thing I saw on my trip was actually, it was the everyday researchers, if you like. Yes, there was the big stuff. There were people doing the storm forecasting and so on, using huge amounts of computational power. But also, there were lots of people who were the practitioners themselves, standing up and giving talks about the research they were doing using cyber infrastructure, using advanced computing techniques. For example, Jeremy Frey, Cameron Naylan, Simon here, are doing great, having very great success blogging the lab. It isn't just the students in the labs who are blogging for their lab notes, but also the equipment itself is blogging. Okay? This is a very interesting world. Everyone's talking about mashups. There are a number of key words that came out of this trip. Despite some purist objections to mashups aren't doing things with data properly, funnily enough, everyone's using them. Lots of Google Maps visualizations. People aren't just talking about grid, they're talking multi-core, they're talking PDAs, they're talking sensor networks. This is a given in the UK because one of the distinctives of UK science is the data centricity, but observing it globally, yeah, it's data centric and people interact around content. You don't go to a web browser and say, I'm going to go and use HTML, or I'm going to go and use HTTP, or I'm going to use a piece of software called a browser. You go for the content. And sometimes it's surprising how software communities forget this. But interestingly, we have these new forms to think about as well, like the workflows and the provenance and the context. It's all very collaborative, but that's not new. Science research has always been collaborative. It's collaborative in different ways in different communities. We have the tradition of the lone researcher in humanities versus the tradition of large teams working in chemistry, for example. But the tools are being used to support the collaborations, as I mentioned before. That's very much the scholarly life cycle perspective. This is the only, I have to apologize as a computer scientist for this. The only new thing in all this stuff, the only new tool that exists, the only breakthrough that's occurred in recent years is actually it's actually people, right? There has been no fundamental breakthrough in computer science in distributed systems theory that says it's any easier to do stuff on distributed systems now than it was 10 years ago. Right? Every few years we get a new technology along, Corba, grid, cloud, whatever's next, and this is the answer. But actually there has been no fundamental breakthrough. The new thing is lots and lots more people are involved, and the networks go faster and so on. So this is the new instrument, and this is where we can get new value. And there are examples of large numbers of users coming together, the community coming together in particular areas and getting benefits from that. There's also doubt about that. People aren't convinced that scientists will share in the same way as teenagers, for example. And the quotes, there's a toothbrush quote yesterday. There's one of those in the bioinformatics world as well, from Mike Ashburner, saying scientists are more likely to share their toothbrush than their data. Right? So there's a big question about whether you can get the sharing, but interestingly, you do. So Open Wetware is a proof of concept. This is a wiki that's grown organically. It has thousands of users, and to be part of that, to publish your biology wet lab protocols, you have to do it publicly, and people actually do it. My experiment is our experiment to explore exactly that behavior across different disciplines. As you all know, better than anyone, everything's increasingly open. So I don't have to say anything more about any of the bullets on that slide. This is a significant and deep one, which I'd love to talk about for hours. There is an instinct in software engineering and computer science and in service delivery to deliver perfect solutions. But strangely, the researchers aren't waiting for those. They're actually taking what makes their life a bit better and using it immediately. So this is a nice sort of pain and gain curve. It would be nice if with very little pain you could have huge gain, but that's unlikely. It would be nice, it would be very bad if you had a very, very large amount of pain to get a very small amount of gain. And I could list a few projects like that, but I won't. And you want to get the sweet spot there where people make a little bit of extra effort, but the return is significant to justify the effort, and maybe with the promise of a longer term return as well. Jam today and more jam tomorrow. And that's where the technologies are being adopted. This is very, very, very important, and I've spent several months now trying to articulate this. It all came about when I went to a grid road mapping workshop in London, where lots of sort of middle-aged businessmen in suits, including me, were put in a room for a day in a highly facilitated event to come up with a roadmap for the future of the grid in the UK. And as the day went on, I was getting increasingly distressed by the whole thing, and I couldn't work out why. And I eventually realized we hadn't actually talked about the users. Right? And the other thing is that I told them at the end they should rerun the whole event with teenagers because it would give a completely different roadmap. But the problem was that everyone was sitting there with this service delivery mindset. We'll improve our services, we'll turn these knobs, and the citizens of the UK will have a better life. No one ever said, looked at it from the user viewpoint at all in that discussion, which is very worrying. But where we see the success coming through in all these talks that I saw on that trip is where the scientists, and supported by their domain ICT experts, not big grid experts or infrastructure experts, are actually delivering the tools and the solutions. And grid is actually seen as something that takes away autonomy because it's very institutionalized. Researchers want to feel ownership. So a really nice example of this, being inspired by a chemist sitting in the front row here, is chemists going into a lab and designing their experiments are well-trained and equipped to assemble their apparatus to do the experiment that they want to do. And researchers in any discipline need to feel the same way about the software apparatus that they're using. And that isn't how it is at the moment. And that's the empowerment piece. And if you can do that, then they start doing, you people delivering services are actually passing some of the creative task over to the researchers. They're feeling empowered, and they're actually developing tools for themselves and developing their own experiences there. That's a hugely significant point. And finally, it isn't just about the web browser as the universal interface to all things through a portal, but actually it's the digital world of the grid and cyber infrastructure meets the physical world through all the devices that we're using. Now, that's kind of my definition of Research 2.0. Those were the 8 points. And I pulled a slight trick here because they actually correspond to these 8 design patterns of Web 2. And the reason I don't start by saying this is what Web 2 is a lot of people instantly get turned off by Web 2, or they think it's hype, or they think it's particular technologies. The really interesting thing about Web 2 is that it wasn't the case that the high priests of the grid and the web sat down and said, here was Web 1, these are the ways we can improve it, these are the problems we're going to have, let's design this wonderful new architecture and these new protocols, and this will be Web 2.0. That didn't happen. What happened is that Web 2 is Web 1 is web, okay? What's happened here is that something interesting was going on, and people sat down and made a set of observations on what characterizes this Web 2 movement. And therefore, it's really a set of observations about how people and computers are working together. That's sort of socio-technical context in 2008-ish. 2005, actually, this started. So you'll recognize some of those slogans, and I think these are highly relevant because this is really a set of social observations about technology. It's not specifically to do with the web, and therefore it's applicable to grid, it's applicable to repositories, it's applicable to any project you're doing. I've sometimes suggested people take their favorite project or their own project and score against these principles and see how Web 2 they are. It doesn't matter what your score is, but the exercise is very fruitful. So the long tail is this increasing scale of participation. It's the long tail science of Peter Murray Rust. Data is the next Intel Inside is the slogan that says your Web 2 site has to have its particular high value thing, like movies on YouTube, photos on Flickr, workflows on My Experiment. So that's the one we extend slightly with science because we want to talk about collections. Users add value is user-generated content, but network effects by default is even if users don't upload content, the sheer number of users of a site is providing value to the other users. People who've used this service have used that service. People who've bought this book have browsed those books and so on. That collaborative filtering, that recommended system aspect comes from the scale of use, even if people don't upload. Excuse me. Oh, sorry. Okay, sorry. So Shall I wait for it to pass? Okay. So if I speak a bit closer to the mics, we should be okay. Oh. So the data piece, yes. So Web 2 sites, Flickr, photos, YouTube movies, My Experiment workflows, all have their particular high-value piece of data that's part of their value proposition. In the case of research use, we're suggesting that you also need to work with collections of different things, not just individual items of data. Users add value is user-generated content, so this is people uploading stuff, but network effects by default is even if you don't do that, the fact that you're using the site, the sheer number of users, actually leads to recommendations to help everyone else. Some rights reserved is this sort of default that content is as open as possible. Perpetual beta is familiar to you all who use Facebook or MySpace or any other Web 2 sites. It isn't the traditional software engineering process of rolling out a new release of software after several months and everyone having to install it. It's a website. It changes every day. It evolves agilely in response to the needs of users. Cooperate, don't control is the principle that says we'll reuse other stuff as much as possible and we'll make our stuff as reusable as possible and we won't keep reinventing stuff. Okay? And finally, software above the level of the single device is saying this is a digital world meeting the physical world through all these different devices. So if you don't take anything else away from my talk today, you now know that Web 2 isn't just hype, isn't just Ajax, Ruby on Rails, isn't just social networking sites, isn't just RESTful APIs for those of the developers in the audience. There are actually 8 design patterns there. You can look them up, see long explanations of all of them. There are papers about this. And that's a really interesting set of things to look at because I think that is really the best definition of Research 2.0, if you like. So what I've done now is we've said a little bit about grid and why it's relevant. We've said, let's look at what the users actually do, where research is going, and this is this piece. Now I'm going to look at why grid has, quotes, failed in the title that Les gave me, and then I'm going to look at repositories. Interesting thing about the Web 2 is we often think about user-generated content, but it's important for the developers in the audience in particular to remember and to recognize that actually Web 2 also brings a lot of ease of use at the programming level. This is a talk that was given at a Grid Meets Web 2 workshop we ran a year ago. And I had Pamela Fox there, she's on the left of the picture, giving a tutorial for grid developers on Web 2. And she now works for Google. She did what we asked her to. She stood in front of the room and she told the grid guys how to develop with Web 2. But 2 other things came across in a big way in that talk. The first was, you guys in the room, you're way too old to do this. The second was, actually, yeah, she'd written some code, blogged it on Sunday, had 6,000 users by Tuesday. There are people in the room who dreamt of 6,000 users, or 600 users, or 6 users. Right? So there's a very, very significant development aspect to Web 2. You don't have to be a specialist. You don't have to go away on a 2-week summer school to learn to use Grid. I've been at the summer school this year for Grid. It's 2 weeks of learning APIs. It's amazing. So this is the empowerment piece. Your web designer in your particular domain can build tools for your researcher to do things. That's very significant. So this is a very positive story. We've learned new ways of doing stuff. We're at the point now where we can assemble pieces to do completely new things. We can bring data together in new ways. We can bring other resources together to work with that. We can visualize it in new ways. We're learning how to link it all up. Another talk I would give would be about semantic web in this context. So that's the positive story about Research 2.0. Now at this point, I have to I'll put this slide in case anyone from the National Science Centre has walked across the road and come into the room, but I think I'm okay. Right. So this isn't meant to be anti-grid, okay, really. And this is me and the grid. Right. So this is a picture from a slide deck of Malcolm Atkinson, who is UK eScience envoy. And I hasten to add, and I've written it on there's nothing wrong with this picture, just using it to make a point. Right, this explains the flow of innovation in computer science research labs, which after 15 years will come out the other end and have mass use by researchers. It explains how you move from innovation on the left through applications research through to deployment and the different stakeholders involved in that process. There's nothing wrong with that picture in that there is a flow like that. But what's wrong with the picture is the direction of the arrows. Okay? So that is a picture about rollout of technology. That is a picture that explains how the technology goes through the pipeline and comes out to users. And what I've been saying to the grid community for a year is turn that round. Don't think rollout of technologies, think rolling of researchers. Okay? And taking that perspective, it's still the service provider perspective. I'm saying sit on the left-hand side, but think about bringing people in instead of pushing stuff out. Standing back, looking at the whole piece, this phrase captures it nicely. What we're doing in research, collaboratively, is knowledge co-production. Not, yeah. So think about that. That's actually what's the task that's going on here. That's what we're supporting. It isn't service delivery. But we're completely set up to do service delivery. We have a service delivery mindset. It's not wrong. It just means it's very difficult to cross the line and see things from the other side. So I'm trying to get everyone to turn the arrows around. So this is interesting. This is an uncontroversial picture. Grid is really difficult to use, to be honest. It does take a 2-week summer school to learn the APIs. I did a Web 2 day at the summer school this year, and there was a great resistance from the program committee on the basis they needed all the time they had to do the Grid APIs. That's really scary. There's also a summer school on semantic web, but that's another talk. So coming along and saying, let's use some of this web stuff there and make this more usable is uncontroversial. But I've been telling a different story. I've been saying, instead of linking up all your resources with these protocols which make it Grid, just link them up with the Web 2 piece. That's where we can couple things together. That's where non-experts in Grid, but experts in their domains, can couple things together without having to be specialists. So this is really interesting that that's controversial, because it seems kind of obvious, doesn't it? But this is a moral for repositories. Grid got itself into a situation where it was doing web-like things, but absolutely not going with web. It retained its identity. It created Grid services, which were very, very much like web services, but subtly different. Because that way it retained its identity. That way the Global Grid Forum, which is now the Open Grid Forum, existed and wasn't just part of W3C and defines a community, and Grid exists. Right? So they actually artificially distinguished themselves from the web. So they object to this picture in a big way. You know, why would you artificially distinguish yourself from the web in order to retain identity? Because what's going to happen is you're going to lose, clearly. Okay? And it's happened. Here's another standard story from the Open Grid Forum, which I'll leave you to think about, which you can also apply in the repositories context. So these are all your resources down the bottom, which are data and computation and storage, and they can be repositories. And at the top, we have applications and devices and users. I just happen to have n of each for convenience. One of the motivations for standards is to avoid this situation where people up the top have to write bits of software to talk to all the different things down the bottom, because then you end up with, for mathematicians in the audience, n squared pieces of software, right? Too many arrows. So what you do is come up with a standard. So in the Grid world, this started with Globus. You put one middleware in the middle, and this makes everything wonderful, because everyone at the top only has to write one arrow, and everyone down the bottom only has to write one arrow, and you have 2n arrows. And that's great. So clearly this model works, and you create a standards organization in order to do this and to implement this standard along the middle that makes everyone's life easier. And you populate it with processes and with people who are good at creating these middlewares. And what happens is this. And actually, you end up with more arrows than you had to start with. Right? And then the standards are a barrier to adoption. Right? So I will leave it as an intellectual exercise to you to work out what the polynomial is to describe the number of arrows on there. But actually, it's now very debatable whether that picture is actually better or worse than where we were to start with, because this is the Web 2 picture. This says development's easy, writing arrows is easy, we can reuse arrows, whatever, APIs change, whatever, it's Web 2, it's cool. So we need something that's between that one, and I don't know what the right answer is, and nor does the Open Grid Forum. Right, final Grid story. Maybe we're solving the wrong problem. So Geoffrey Fox, a colleague of mine in the Grid community, some of you may know, to summarize his current view on Grid in one sentence is, e-science good, Grid bad. And he observes that Grid was trying to harness all these remote resources in order to bring them together to solve your scientific problems. But we have a new problem. And the new problem is that we have more resource in our laptops, desktops, and our servers in terms of multi-core than we have software to use. Right? So it's a completely different problem. We've been solving the wrong problem. Now that's an interesting observation. So let's move on to repositories. I'll leave you with a few thoughts which I hope provoke some discussion. The first is they shouldn't be called repositories. I'm a bit stuck on a better word for this. I chaired a workshop at the last Open Grid Forum on digital repositories, and there are various people in the audience making this observation, particularly actually a lady from France, because I think maybe there's more of a problem with the French verb. But the problem is the word repository implies it's a place you stick stuff away, or a place that things go to die, right? They repose. And actually that conjures up all sorts of wrong images and even political problems. So they're actually reactive things, repositories, you know that. So if you call them a data center, wouldn't that be better in terms of trying to attract attention from your university institutions for supporting these things? Because that's really what they are. What's the difference between a repository and a data center? Right? And then I've been discussing this over the last few weeks with various people, trying to come up with another, we don't have another word, but the sort of theme of discussion, and I'll leave this with you for homework to come up with another word, is actually, it's a much more actively curated place with lots of different kinds of visitors. So actually I quite like the zoo. The zoo thing came out of watching Tim Minchin last night with the dancing bear in the last one. I know some of you were there. But you do have all these different people. Think of zoological gardens, or think of parks in America, or think of gardens in cities in the UK. You have got different kinds of visitors, you've got people looking after them, you've got active curation going on, you've got roles for experts occasionally, you've got security issues, okay? You've got dancing bears if you're Tim Minchin. So this is much more. Now, I'm not proposing you should go back and say instead of a repository, we want to build a zoo. But I think you get my point that the word repository has some problems. So I'm leaving you with that one. What I'm trying to get people to think here is, are we solving the right problem? So here's an interesting thing that occurred. So some of you may have heard Carol Goebel give a keynote at the Data Curation Conference last year, where she talked about curation of workflows, of services. So instead of the data, it's the processes that lead to that data and that handle that data. So it's basically saying, it's all very well having the data, but what about everything else that went with it, and what about the other half of the story? So this is questioning whether we're solving the right problem. And Carol and I wrote an article recently, which is coming out in Educo's review in a couple of weeks. And in it, we had this definition of actually what you want to do about curation of processes. And I really like this bulleted list. And we didn't realize this when we wrote it. I realized it afterwards. That that's actually quite nice to look at from, if you like, a library perspective. Because all the things we're saying you want to do with a process, a research process there, are actually things that you might want to do with a book-ish, modified to a digital process. But you want to find them, find out alternative copies, know what the alternates are. You want to understand how to use them and predict, have some expectations about that. You have to understand the conditions of use, permissions, licenses, and costs. You need to know something about the adoption of these and the provenance so that you can maintain them, and so on. Okay, so this is really interesting because this isn't what happens in repositories at the moment. This is again questioning: are we solving the right problem? Because this is an important part of the problem as well. This is a point that I found myself making repeatedly in the context of the current digital economy program from our funding councils, where they're talking about digital sort of all the stuff we've been talking about, if you like, and its transformational effects on society. And there's lots of discussions about e-health and transport and so on. And I keep saying, well, actually, there's a really, really good case study that's already happened that you can look at to learn a lot of things, right? And that's what's happened in music and broadcast. So it's gone now to a point where people are producing in studios digitally all the way through the chain digitally to us listening to things. It's analog at the last step. And isn't that the same as science, right? It's gone from a point where content creation was highly institutionalized by a small number of providers to the point where people can create content of the same quality in their bedrooms, okay? And the publication process has changed so that anyone can upload stuff and share it on the web. So this is a really radical transformation that's occurred to an industry through digitalization. It's the democratization of music, if you like. But isn't that a strong analogy for what's happening with the research, and can't we learn something from that? And has this finished? No. I mean, only last week we had the internet service providers telling us, writing letters saying, don't copy music, it's bad, right? Which may or may not have any effect. But it's a big, slow process in terms of the impact on the business and how that evolves. But there are lessons to be learned there. In the creation of various bits of e-science software over the last few years, and in particular when we were designing the My Experiment website for scientists, we wrote down the principles of software design for adoption by scientists. And I think these are applicable to those of you developing software in the repository context and tools for using them. And there's a paper about this which you can read. It's on ePrints in Southampton. And there's a whole set of things that's really about, on the left, they're the things you've already seen in this talk, but they all require user engagement. You have to go on a journey with your users. And on the right are the ways you get to go on that journey. So I recommend that paper, but you recognize some of these things. So don't force change, jam today, more jam tomorrow, just in time, just enough is the perpetual beta. Act local, think global is really, really controversial in computer science terms. This says solve the specific problems for the users you've got today and then refactor in order to come up with more generic solutions so you can deliver solutions to other users. That's the opposite to what we teach our students to do. Enable users to add value. You recognise the Web 2 principle there. Design for network effects. So those are good. And then let's finish with this cloud thing. So some people say grid's rebranded as cloud. It's all the same. Some people say it's quite different in philosophy. But let's look at one specific aspect of cloud computing. So this is, I've just picked up a few things from the press here. So going back to, what date is this? This is about August last year, which is just before cloud really hit. It's been quick, cloud. People beginning to say software as a service and mashups. Is this the end run on IT departments? And then we get to June this year, the end of the IT department. Is this in the cloud? And then books coming out. The IT department is dead, author argues, right? So what people are saying is that if your company has still got an IT department in 10 years' time, then it's a company that's going out of business because the future is people using devices interacting with the cloud, okay, which is the services being provided by Google or Amazon or big data centers all over the planet. And there isn't this piece in between, which is your institutional data center and your information services. This is interesting, isn't it? I especially feel that at the moment in Southampton, where there's, and I know this has happened elsewhere, where the central computing services have assimilated the system support software all over the university into themselves. I think, yes, but they're not going to exist in 10 years. Or maybe that's why you did it. So this is interesting, right? Because this challenges the institutional repository piece a little, doesn't it? But I don't want to say that institutional repositories are dead. I want to say something slightly more general. So, here's a thought experiment to finish with. Imagine that ePrints, or DSpace, or Fedora, or whatever, isn't something that you download, free software, as Chris was saying earlier, and run on a server that you've somehow appropriated from your institution or you persuaded them to invest in as part of services. But instead, imagine that if you want an ePrints, you just go to the cloud and say, give me an instance of ePrints that you can configure the way you want to. You can customize the way you want to. It's your ePrints. What I'm saying is that there's an ePrints factory in the cloud. Right? Now, this is completely realistic. It's a discussion I'd love to have with some of you. Absolutely, we can do this. So, ePrints.org is not somewhere you go to download software, but somewhere you go to say, make me an ePrints. So anyone can have one. You can make one for your chemistry lab, you can make one for your institution, you can make one for your national data center, you can, individuals can make them, institutions can make them, networks can make them. In fact, all those behaviors are visible already with people downloading and running ePrints. Yes. Yes, this is good. I'm aware. Okay. So that confirms what I'm saying. It's doable, but that's not the thought experiment. So imagine we weren't starting from here. Imagine we weren't starting from having IT departments and we weren't starting even from having libraries, but you just had the community of academics and scholars and researchers doing the Research 2.0 piece that we talked about earlier. And people can just download and make repositories, or whatever repositories are called. That would then self-organize, wouldn't it? Okay. Now, in this vision, I'm not thinking about repositories necessarily being where stuff is stored. It's actually where you're doing all those other things that are in my garden in terms of making it available to different users, in terms of curation, and so on. Because the storage could be all over the place, and there's a lot of discussion we could have about that as well. Which means you can have multiple repositories over the same content and so on. So that would evolve, that ecosystem, that set of stakeholders, which is you guys, would evolve this into a particular configuration of multiple ePrints. And I wonder what that would look like. Would it be lots of subject-specific stuff? Would it be institutional repositories? So this is an organizational question. It's a question about the ecosystem and about stakeholders. The technology is completely doable. So now we ask the question, is the institutional repository dead? Do you think in those circumstances you would still create institutional repositories? I think you might, actually. It's interesting, isn't it? So that's the closing thought of the institution of repositories. So this is kind of a nice closing bookend on Dorothea's opening talk. To close, this is what I've said. How repositories can avoid failing like the grid, understand what the users will need. Now, they don't know what they're going to need. You have to work together. Okay, it's a journey. And that's not trivial, as the grid community has demonstrated. But at least we should start by doing it, rather than doing it as a retrofit. Be open-minded. Are we actually solving the right problem? Should they be called repositories? What about curation of process? Possibly grid has been solving the wrong problem. Don't create artificial distinctions from web. I'm really positive about this one after the Open Repositories Conference in Southampton earlier this year, which was very, very, very webby. I thought that was great. Occasionally, it's still visible that there's a distinction in places, but it doesn't have the grid problem of deliberately avoiding being web, which it would be such a mistake. Be careful of these standards because they can actually be barriers rather than enablers in such a big way. And think cloud, imagine that repository factory, my little thought experiment. And finally, this time next year when we get together, let's have a competition on new names of repositories. Dorothea is shaking her head. Okay, that's it. Thank you very much. Let's have some discussion.
So